All right, this is a tutorial on some of the problems with circular motion and circular force and rotation and that kind of stuff. So we're looking at a circular motion problem here. We've got a ball on the end of a string being held so that the ball rotates horizontally. You got a 50-gram mass or 0.05 kilograms, radius 40 centimeters or 0.4 meters, moving 2.5 meters per second. So if we look at that, what we really want to know is what is the centripetal acceleration, what's the horizontal component of the tension force, and what's the vertical component of the tension force. If we go back to our diagram here, we can see that if I'm rotating horizontally, the ball is not falling, then this weight force equals the vertical component of the tension. Because how do we know that? The ball is not dropping because it's rotating horizontally. The horizontal component of the tension force is going to be your centripetal acceleration. That is, we don't really need to do any trig to get this. We can get the horizontal and vertical component of the tension separately. And it's a little beyond the scope of our course to do the trig to actually get this vector, so we're just going to leave that alone. But the vector would be adding in this direction. So what is the centripetal acceleration? So what's our formula for centripetal acceleration? We get our A sub c, because we're dealing with a circle, is equal to v squared divided by r. So what did we say? It was going 2.5 meters per second, quantity squared, over the radius of 0.40 meters. We'll end up with units in meters per second squared because we get meters squared per second squared on the top and then meters on the bottom. One of those meters cancels out and gives us meters per second squared. But then we take 2.5 squared divided by 0.4. We get an acceleration of 15.6, we'll say, meters per second squared. And that would be our centripetal acceleration. Now, the tension force will be the force due to the rotation. And so Newton's second law says F equals ma. In this case, it's the centripetal force and the centripetal acceleration. Since we just calculate that, we could just plug it in, or if you didn't have it, you could say F equals m v squared over r. Either way. Since we just calculated it, I'm just going to plug in the mass and the acceleration we already calculated. So the mass of that was 0.050 kilograms. And the acceleration we calculated in the previous part is 15.6 meters per second squared. And I'm going to use the version that I held my calculator with more decimal places. Times 0.05 is 0.78 newtons of force. And that would be the answer to part B. Now, part C, we want to know the vertical component of the tension. But we said that the vertical component of that tension, where this was the horizontal component, the vertical component is just equal to the weight of the ball, which is equal to mg. And so we're going to put in our mass, 0.050 kilograms. And G, we're going to use our rounded off figure of 10 meters per second squared. So 0.05 times 10 will give us 0.5 newtons in weight force, which ends up being our vertical component of the tension. And we know those have to be equal because the ball is spinning in a horizontal circle and is not falling or rising. Right, this has been a brief tutorial of circular motion. In particular, we're spinning the ball on the string, but it does work us through the calculations from this chapter.